So in this chapter, we'll be going over radicals and some of their applications. So we have to start with the square root. So the square root is the inverse operation, which you can think of as the opposite operation of squaring an expression. So it looks like this. It has that little square root symbol, and we call that the square root of a. So this symbol is called a radical. And what's underneath it, in this case, is the a. That is called the radicand. So the relationship between squaring something and the square root is this right here. If b equals the square root of a, then b squared equals a. Okay, so it's important to note here, fit it in right here, the square root of a, the square root is just an exponent. It is an exponent of 1/2. So the square root of a equals a to the 1/2 power. Okay, so let's do a couple examples converting between the two forms. So let's rewrite each example using the square root symbol. So we have 5 squared equals 25. So what this means, based on this definition above that I highlighted, this means that 5 equals the square root of 25. So the square root of 25 is 5. So you have to be able to think backwards from when you're squaring something. Next one, 10 squared equals 100. So this one will be 10 equals the square root of 100. Okay, so it's just the inverse operation of squaring something. So let's do a couple other examples. So this button is also on the calculator. So first example, we have the square root of 64. So the square root of 64, we have to think to ourselves, I'm going to use an x for a variable, what squared equals 64? So when you're thinking this to yourself, you have to think, maybe go through your tables, your little times tables, and say 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on, until you get 8 times 8. 8 times 8 is 64. That means the square root of 64 equals 8. So that is because 8 squared equals 64. Okay, the next one, we have negative square root of 49. So the negative square root of 49, the negative is on the outside, so it's coming along for the ride. The square root of 49 equals 7, so this is negative 7, and this is because 7 squared equals 49. Okay, next one, we have the square root of 9 plus 16. So we have to simplify what's inside of here first. We get the square root of 25. The square root of 25 is 5 because 5 squared equals 25. And for this last one here, we have the square root of 9 plus the square root of 16. So it looks similar to the one we just did, except we have to actually do them separately. The square root of 9 is 3. The square root of 16 is 4. So 3 plus 4 gives us 7. And I'm going to put a little note over here. That's because 3 squared equals 9 and 4 squared equaled 16. So you just have to make sure that you're able to think backwards from squaring something. Okay, so for a couple little notes here, a number that has a rational number for its square root is called a perfect square. So a little definition for what a perfect square is. So something like 36 is a perfect square. And this is a perfect square because the square root of 36 equals a rational number, which is 6. So 4 is a perfect square because 2 squared equals 4. 9 is a perfect square. 16 is a perfect square, 25 is a perfect square, and so on. Something that may be a little bit less obvious is something like 1/4. 1/4, something like 1/4 is also a perfect square because the square root of 1/4, which once again may be a little bit harder to think of off the top of your head, this actually equals, thanks to exponent rules, because the square root is just an exponent of 1/2, we can do this. We can do the square root of the numerator divided by the square root of the denominator, which is 1. Square root of 1 is 1. Square root of 4 is 2. So it equals 1/2. 1/2 is also a rational number, so 1/4 is also a perfect square. Okay, and the second note here is we can only take the square root of numbers greater than or equal to 0, so no negative radicands for now. That will give us something called imaginary numbers, so we're not doing that for now. Okay, so for some applications using this square root, we have the distance formula. So using the Pythagorean theorem, we can find the distance between 2 points, x1, y1, and x2, y2 in the rectangular coordinate system. So this right here is called the rectangular coordinate system. We have a horizontal axis and a vertical axis. And this allows us to plot points. And the points that we plot are x, comma, y. So let's say we had 2 coordinates here. Let's say we had one was right here. This was x1, y1. And then we had another one, over a little bit, we had another one right here. And this was x2, comma, y2. And let's say we wanted to find the distance between them. So that straight line connecting them, we want to find that distance between them. So we can't just count grid blocks to see how far away they are. So what we can use is actually the Pythagorean theorem, which I will write down if we don't remember what that is. So the Pythagorean theorem essentially relates all of the sides of a right triangle together. So a right triangle, we just have a triangle that has a right angle in it, so a 90-degree angle. If this is side A, if this is side B, and that is side C, then the Pythagorean theorem tells us that a squared plus b squared equals c squared. So it's important that C is the hypotenuse. The hypotenuse is the side opposite of the right angle. So using that idea here, we can actually create a right triangle. We can go vertically down, go horizontally across, and we create this right triangle. The vertical distance here is going to be the difference in the y coordinates, which would be y2 minus y1. The horizontal distance would be the difference in the x coordinates, which would be x2 minus x1. So using the Pythagorean theorem here, it's a squared plus b squared equals c squared. That's going to be, it's going to look a little messy. I'm going to write it over here. It's going to be x2 minus x1 squared plus, so that's like a squared, plus b squared, which would be y2 minus y1 squared, equals the hypotenuse, which is d squared. So if we use that definition of what a square root represents, we could take the square root of both sides here. We end up getting the square root of x2 minus x1 squared plus y2 minus y1 squared equals d. So that's just converting between that squared format to the square root format. So that d is now solved for, so that is actually the distance formula. So the distance between 2 points on a rectangular coordinate system is going to be d equals, so we have one point being x1, y1, the other one being x2, y2. It's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It's pretty much just plug and chug here. So if we want to find the distance between -1 and 4 and 3, -2, let's plot these so we get an idea of what they are. So -1 comma 4. So -1 comma 4 means we are going to the left 1 from this origin spot right here in the middle. So we're going to the left 1 and we're going up 4. So to the right is the positive x values, so positive x values. To the left is the negative x values. Up is the positive y values, and down are negative y values. And the point here in the middle would be 0, 0. Okay, so this is the coordinate -1, 4. The other coordinate was 3, -2. So that's to the right 3 and down 2. So we're trying to find this distance right here. So this is D. So we're trying to find how far away that is, where each grid counts as one spot. So once again, we can't just count them because it's not perfectly in line, it's at an angle. So we have to use the distance formula. So we have two coordinates, so once again, we have x1, y1, so we can just let the first one be x1, y1, the second one be x2, y2. And we're going to plug those in. So it's going to be the distance between those two coordinates is going to be x2 minus x1. So that's 3 minus -1 squared plus y2 minus y1. That's -2 minus 4 squared. So that's going to be 3 minus -1 is positive 4. And then plus -6 squared, -2 minus 4. And this gives us 4 squared is 16. -6 squared is positive 36. So this is going to give us radical 52. So you can read this as radical 52. You can read it as the square root of 52. They're both going to mean the same thing. And we're going to just leave it just like this. There's a way we can simplify it, but for now we can leave it like this. I will type it in. Let's get a decimal answer here. So plugging this in the calculator, 52 is not a perfect square, so it's going to be a decimal. So it's going to be about, I'm going to round to the nearest hundredth. It's about 7.21. Okay, which hopefully makes sense if you look at it on the graph that we graphed it. Okay, let's do one more for this one. So let's find the distance between 5, -1 and 0, -4. So 5, -1, that's to the right 5 and down 1. And for the other point, it was 0, -4. So that means a horizontal distance of 0, so it doesn't move, and then we go down 4, so it's right here. And then we're looking for this distance right here that connects them. That's going to be our distance D. So just by looking at this, it looks like it might be maybe about 6 or 7 units long. Okay, so the distance formula, we have our formula, and then it's going to be our 2 points. So I'm going to let the first one be x1, y1, the second one be x2, y2. So it actually doesn't matter which one you let be which. You could have flipped it and it still would give you the same answer. And now we're going to plug these in. So the distance is going to equal the square root of x2 minus x1. So that's 0 minus 5 squared plus y2 minus y1, -4 minus -1 squared. So simplifying inside of here a little bit, we're going to get -5 squared plus -4 minus -1, that's -4 plus 1, that's -3 squared. And simplifying this, we're going to get 25 plus 9. So we get D equals the square root of 34. So we can plug this in the calculator. Once again, it's not going to be a perfect square, but we're going to get around 5.83. So we should have known it was going to be a little bit less than 6 because radical 36, the square root of 36 is equal to 6. 34 is less than 36, so we knew it was going to be a little bit less than 6. Okay, so I guessed like 6 or 7. I knew it was going to be greater than 5 because the horizontal distance right here is 5. And that distance is actually the hypotenuse. And a little bit of extra information here, the hypotenuse is always the longest side on a triangle, so I knew it was going to be greater than 5. Okay, so let's do one more application, and then we'll be good. So, for example, a formula for the velocity of an object in feet per second after it has fallen a certain distance is this formula right here. It's v equals the square root of 2gh. So g is the acceleration due to gravity, and h is the height at which the object has fallen. And on Earth, the acceleration due to gravity is 32 feet per second squared. So acceleration is going to be distance per unit time squared. So that is the acceleration due to gravity on Earth. So suppose a sandbag is dropped from a hot air balloon. We wanted to determine the velocity of the bag after it's fallen 100 feet towards the ground. And we're going to round to the nearest hundredth. Okay, so let's see what we have for our givens. We know we're going to be using this formula, so it's v equals the square root of 2gh. We are looking for v, which is good because that's what it's solved for. We are given h is 150 feet. And we know that the acceleration g due to gravity on Earth is 32 feet per second squared. Okay, so don't worry too much about the units, especially for acceleration here. If you haven't seen it before, it probably looks pretty confusing. So for velocity here, now we can plug in all these numbers. So it's going to be velocity equals the square root of 2 times g, which is 32, times h, which is 150. Okay, so all we have to do is plug this in. We get v equals the square root of 9,600 after we simplified that radicand. And now we can plug this into the calculator. The instructions said round to the nearest hundredth. So plugging this in the calculator, we get 90, we end up getting 97.9795. To the nearest hundredth, it would end up being 97.98. So the velocity after it's fallen 150 feet to the ground on Earth would be 97.98, and the units would be feet per second here. Okay, so that's just a small little application for using a square root. So just remember that it's the inverse operation of squaring something. It's an exponent of 1/2.